Okay. Today we are not supposed to have a physical class here. Uh, I think next week it will be okay. So we went through factors as our first topic. Then we started expansions. We went through binomial expansions where the power is 2 and 3. So in 2.3, we go for trinomial expansion. Nomial means the terms, huh? The meaning of nomials means the terms. Trinomial means 3 terms. Here we consider a plus b plus c quantity squared. We don't have to go beyond that. We can just stay with square. So you can expand it like this: a plus b plus c times a plus b plus c. So first you multiply everything by a. So you have a squared, then you have ab, finally you have ac. Then you have to multiply everything by b. So first product will give you ba, which is ab. Sorry. You can write ab just beneath this so that you can collect similar terms easily. Then b times b, b squared, I write it here. B times c, bc. Then multiply everything by c, ca. ca is ac, the same. C times b, bc. It's here. Then you have c squared. Now add them up. You have a squared plus 2ab plus 2ac plus b squared plus 2bc plus c squared. Now you can collect, you can write it in a nice way. Like you can write a squared, b squared, and c squared together. Then write the other terms in the same order: 2ab, then 2ac, finally 2bc. So that's the expansion. Now this is how you have to go with the trinomial expansion. You have 3 terms. So you square each and every term. So you get a squared plus b squared plus c squared. Now you need to take care of the other 3 terms. This is how you do it. You close c and just multiply what you see. 2 times a times b, 2ab. Then you close this. What you see is 2a and c. So 2ac is the product. Then you close this. What you see is b, c, and 2. So get the product, 2bc. Basically, that's it. Close one at a time. Right. I forgot to insert that square. You have to raise, I mean, a cube of a trinomial is not important to us. We need these type of examples. Now we'll see how to do this. Now, first you have to square each and every term. 1 squared is 1. X squared is this. Y squared is also that. After that, you need to come up with 3 other terms. So close the last term in the expansion, not in the expansion, in the bracket. Get the product of the terms that appear after that. You have 2 times 1 times x. The numbers appear are 2, 1, and x. Get their product. 2 times 1 times x is 2x. Now close this. The product is equal to 2y. Finally close this. The product is equal to 2xy. I mean, there are no similar terms. Therefore, you cannot, that will be the last stage. Last answer, final answer. Now go for this. Square each and every term. 2 squared is 4. Now, this is in fact minus 6. So if you square it, it will be positive. You get x squared. The square of y is positive. Y squared plus y squared. Now close this. Now you see 3 terms. 2, now you have to consider this with the sign. 2 minus 6 and 2. So first take care of the sign. There's only one negative sign. Therefore, when you multiply, that sole negative sign will make it negative. What is it? 4x. Right? 2 times x. 4x. Now close this. You have 2 times y. The product is positive. It is 4y. 4y. Now close this. It is 2 times y times minus x. The only negative sign will make it negative. The product will be 2xy. Now go for this. Now there are two trinomials. First take care of the first one. First square them. 1 plus x squared plus y squared. After that, close this. What you see is 1 minus 6 and 2. So it is their product is minus 2x. Now close this. Their product is 2y. 2 times 1 times y. 2y. Finally, when you close this, you have minus 2xy. Now we have to expand this. When you expand this, you can write those terms here. Instead, if you write the terms just below them, you can easily gather the similar terms. So I'll write the terms just below them. So 1 squared is 1, x squared. Then you square y, y squared. Now close this. This is, when you multiply these 3, you get 2x plus 2x, right? There are no negative signs attached to the elements you see. Therefore, plus 2x. Now, when you close this, you have minus 2y. 1 times 2 times minus y. Minus 2y. When you close this, you get minus 2xy. So when you add them, you get 2x squared, 2y squared. These two will be 0, 0. This is minus 4xy. These two will go away. So that's the final answer. Now we'll go ahead with this. First square these terms. Now close this. You get plus 4x. Close this, you get minus 4y, because 2 times minus y times 2. Close this. You get minus 2xy. Minus 2xy. After that, the sign before this is negative. So have a negative sign in front. 1 squared is 1. You have x squared. You have y squared. After that, you close this. You have 2 times 1 times minus 6. So minus 2x. Now close this. All the terms are positive. You have plus 2y. Now close this. You get minus 2xy. Now this sign will change all these signs in the bracket. Now 4 minus 1. Now add similar terms. You get 3. X minus x squared, 0. Y minus y squared, 0. Now 4x plus 2x. That will make it 6x. Minus 4y minus 2y, because this minus sign will affect the sign in front. Minus 4y minus 2y means minus 6y. Plus minus 2xy plus 2xy. 0. That's good. So this is the answer. Right. You try to do, I'll assign some examples. So you can do problem 7. I'll do some of them for you. At least, problem A is not necessary. B to G. First, to take this down, it is not B and G, B, C, D, E, F, G, H, G, all the way up to G. First, to take this down and then do these parts. Right. I'll do some selected examples. I'll do part D. Now, you can expand this square each and every term. This is 1, this is x squared, this is x to the power 4. Now close this and get the product. You get minus 2x, right? 2 times 1 times minus 6. Then close this. You have 2x squared plus. Then close 1. So this sole negative sign, the only negative sign, will make it negative. 2 times x squared, 2x cubed. Now plus, expand this. So 1 squared, x squared, plus x to the power 4. Now close this. You have plus 2x. Then close the term in the middle. So it will make the product negative. Minus 2x squared. Finally close this. You have minus 2x cubed. Add them up. So these two will go away as well as this pair. So you get 2 plus 2x squared plus 2 to the power, 2 times x to the power 4 minus 4x cubed. D. Then I'll do F. Part F. You can expand it, square each and every term. Then close C. You have minus 2AB. Close minus B. You have 2AC plus. Then close A. You have minus 2BC minus. So keep the negative sign as it is and expand the bracket. You have A squared, B squared plus C squared. After that, you have, when you close C, minus C, you have plus 2AB. When you close B, you have minus 2AC. When you close A, you have minus 2BC. A minus C will go, B minus B squared go away, C minus C squared. Here, minus 2AB minus 2AB. So it is minus 4AB. 2AC, this negative sign will make it positive. 2AC plus 2AC. 4AC. Here, minus 2BC plus 2BC. Those two will go away. Now the last one. You can expand the first. a squared plus b squared plus c squared. Then close C, you have 2ab. Close B, you get 2ac. And finally 2bc. Now go for this. So you have to add these. After that, when you close minus C, you have 2ab. When you close B, you have minus 2ac. When you close A, you have minus 2bc. Then in the third case, you get the same set of squares. Close C, you get minus 2ab. Close minus B, you have 2ac. Close A, you have minus 2bc. Now square each and every term. Then close C, you have minus 2ab. Close B, you have minus 2ac. Finally, close minus C, you have 2bc. Even though there are four terms like this, two of them are positive and the other two are negative. Here, two of them are positive and the other two are negative. These two are positive, these two are negative. So these go away. It leaves us with 4a squared plus 4b squared plus 4c squared. If you want, you can pull 4 out, or you can leave it like that. There's one thing I need to, this is an example. I forgot just one of them. What happens if you have two negative signs like this? Still, you have to raise everything to their respect. I mean, their respective squares. Now close this. When you close, you have to close with the sign. You have 2 times 1 times minus x. So minus 2x. Then close this. You have minus 2y. Then close 1. Minus times minus plus. You have 2xy. Right? Because if you close 1, 2 of them have negative signs. So you have 2xy. Right. You take that down. Okay. Uh, okay. Once the expansions are over, we can turn around and see some simultaneous equations. Here, solving three simultaneous equations or solving uh, sets of three simultaneous equations is not necessary here because when you start functions, almost all the time, you need to solve pair of simultaneous equations. Hmm? Okay, I'll do some examples. You have some exposure in this anyway, but I'll do some examples. Right. In this case, I mean, these coefficients are the same. So by addition or subtraction, you can eliminate one variable. Hmm. So this is a problem we'll label after that. This is the easiest type of, I mean, this is the simplest form of simultaneous equations. Now, when you add them, you can easily eliminate y. Hmm. If we can eliminate a variable either by addition or subtraction with the same, having the same degree of difficulty, usually addition is preferred, right? We'll go for addition there. This is so if you add 1 and 2, you get 4x plus 0. I mean, plus y minus y is go. I mean, that's 0 is equal to 20. You know, when we add equations, some of you have learned it like this. Okay, you add the left-hand side of the first equation, left-hand side of the second equation is equal to 12 plus 8. Sometimes you do it like this. Uh, this practice is uh, not very good in A levels because you know when we encounter very complicated equations, this will eat out a lot of time. Say for example, if you have some equation like this, even in F2 also you say you have something like this, something like this. Say the next equation is also very similar to this. Sorry, F1 minus the same thing. So if you have something like this, Just by addition, yes, you can eliminate that. But what happens if you try to follow this method? Then you have to do this part plus the whole thing is equal to the right hand side. So it takes a lot of time. So don't do it like that. This approach is really rudimentary. In O levels, you can do it. So you can show your work in O levels. The degree of difficulty of these problems are very low. Therefore, you can do it. There's no harm in that if you follow a method like this in your O levels. Instead, you add column wise. That would be better. Like here, 2x plus 2x, 4x, plus y minus y, 0, that's gone. This is 20. Now, after that, when you encounter something like this, sometimes in O levels, I have seen people doing it like this. That's correct. But don't do it. Again, the same argument. Think about this. If you have something like this, how would you cope up with that? Say you have to solve something. Now, how would you follow this method? Then you have to write the whole line and write the same thing, and he also had to write the same thing. Right? It takes time. You have to write how many characters? 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 17, 18, 19, 20, and 40. Twice, because you have to write it twice. 40. So don't do that. I mean, if you stick to this type of very basic method, even though it's correct, uh, I mean, your work will be really slow if you do it like that. So don't do it in that way. Here, this 4 acts as a product. So in the other side is a division. If you have a simple number like this, you can straight away divide both sides by x rather than indicating it. Just x is equal to 20 over 4. So straight away you in here, it's so simple, no? So you can divide both by 4. So x is equal to 5. This would be good. This method would be good enough in A levels. Now, divide both sides by 4. So x is 5. Now substitute that value there. Probably 1 would be better. Because if you substitute it there, you have to take y to the other side. Here you don't have to do that. 2 times 5 plus y is 12. So this is 10 plus y is 12. You take this 10 to the other side, it will appear as minus 10. So 12 minus 10 is 2. That's the simplest type. Now consider this one. I label this as equation 1. Now you have to equate coefficients. Here this is 3. If you make it 3, you are done. So you can multiply the second equation by 3. That will make it 18. Then you can subtract. So multiply equation 2 by 3. Right? So it will make it 3x. Subtract the first equation from what you have. So when you multiply this by 3, you get 3x. 3x minus 3x, 0. Right? So we'll do it like that. Again, now when you encounter something like this, in O levels, you have this practice, which is in fact correct. You write the left-hand side of 2 multiplied by 3 minus the left-hand side of this. Again, this is correct. However, if you try to do this in a very complicated problem, it's a waste of time. So don't do it like that. Do it column-wise, term by term, because then you don't have to write the term that is going to be eliminated. Now take this for example. Now, when you multiply this by 3, this will be 3x. 3x minus 3x, 0. So that's gone. Now multiply this by 3. That is 18y. Right? So 18y minus 4y. In the right-hand side, you multiply this by 3. So that is 60 minus 18. So this is 14y is equal to 42. Divide both sides by 14. So y is equal to 3. Now substitute that value there, probably here in equation 2 to find x. So x plus 6 times y is 20. This is in fact 18. So take that to the other side. So x is 20 minus 18, which is 2. That's the second type. Now we'll do this example. Now here, a direct multiplication of one equation doesn't get you anywhere. Look, if you multiply this by anything, I mean, you cannot make it 4. Those coefficients are totally different. Now, either you have to make these two equal. To do that, you have to multiply the first by 5, second by 7. That's tough, right? Multiplication by 7, we don't like it. Why don't we go for this? Multiplication by 3 and 4. That would be better. So you multiply the first by 3, second by 4. Multiply the first by 3. Second by 4. Then you have to subtract. When you subtract, it's better to subtract this guy from here because this is already negative. So I'll do it in the other way around. I first multiply this by 4. Then subtract this times 3. Because if you do that, you have to multiply in this side. You have to subtract this guy from 20. So that will give you a positive number. That's better, right? Now, okay. Think about x's. When you multiply this by 4, it will make it 12. This is also 12. When you subtract, that is gone. So you don't have to write that. Now go for this. Okay, you multiply this by 4. That will make it 20y. Minus, you multiply this by 3. What would you get? You get minus 21y. Minus 21y. Right? Now multiply this by 4 in the right-hand side. That will make it 100. Minus, multiply this by 3. That is 18. So 100 minus 80. Here, you know, these two negative signs make it positive. So you get 41y. Here, when you subtract, you get 82. Now, it's easy to divide both by 41. Because when you divide by 41, you know 4 is multiplied by 2, 8. 1 is multiplied by 2, 2. So it is exactly twice of 41. So divide both sides by 41, you get 2. Now subtract that value here, or here, anywhere. I'll take 2. 3x minus, plus 5 times 2 is 25. 3x plus 10 is 25. You subtract. that is 15. Divide both sides by 3, you get 5. Hmm, right. So I'll leave you the problem 8 as a homework problem. You do problem 8. Hmm. Okay, I'll just assign, no, do all parts, all 5 parts. Hmm. You can do it as a homework problem. You can take these things down. You do problem it as I'll leave it for you as a homework problem, and we'll go for fractions now. Then we can come back to functions. Hmm? Okay. Now, we'll go for problem number 14. First, let me write 4, like fractions. Before taking up the problems in parts in problem 14, I'll do a couple of examples. Here we need to simplify. Right. Now we need to simplify them in a certain specific way. Now, when we take the common denominator, you have to include each and every factor once, right? That's a common denominator. Now, if you compare with it with this, earlier you had x minus 1. Now you, in addition to x minus 1, now you have two extra factors, right? So a should be multiplied by those two factors as well, hmm, to have the equality. Now here b, you had x plus 2 earlier. Now the downstairs is multiplied by two extra factors. So upstairs should be multiplied by the same pair of factors. The same case is true for this term. You have to multiply by x minus 1 times x plus 2. After that, you have to expand. Don't try to expand the downstairs. Just leave it like that. Don't try to multiply them. But here, expand this product. So a times, we went through this earlier, I guess, x squared. We have 3x plus 2x. You don't write like plus 3x plus 2x. Then you have to write the whole thing again. Therefore, add them together, like 3x plus 2x will give you 5x. 2 times 3, 6. X times x, x squared. 3x minus 6. That will make it 2x. Minus 1 times 3, minus 3. And finally, x times x, x squared. 2x minus 6. That will make it plus 6. Then minus 1 times 2, minus 2. After that, there's one more step. Now you can gather similar terms. Similar terms means like terms containing x squared. How many terms are there containing x squared? 1, 2, and 3. So if you just consider those three, should I write it together? That is not necessary, but since this is our very first problem, I'll do it like that. I write those three terms together. Then the terms carrying x, there are three such terms, right? So this is 5ax. This is 2bx, that is cx. Then there are three constant terms, 6a minus 3b minus 2c. Now from these three, you can pull out x squared. Right? From these three, you can pull out x squared. You get a plus b plus c. From these three, you pull out x. You get 5a plus 2b plus c. Right? So you have to keep the answer, leave the answer like that. That is the first one. Second, in the second problem, you know this what we have, a over x minus 1 plus b over x minus 1 quantity squared x plus 2. Okay, now this is the tricky part. What is the common denominator? Now, when you have something like this, don't multiply everything. Like take this for example. What is the common denominator? If you go for 3 times 9 times 8, it will be 216. But 9 contains 3. Therefore, 9 times 8 would be sufficient. Right? So similarly, x minus 1 quantity squared contains x minus 1. Therefore, the product of these two would be sufficient. You don't have to go for x minus 1 cube. Now compared with this. Earlier we had x minus 1. Now we have x minus 1 quantity squared times x plus 2. So this is multiplied by 2 extra factors. What is that? The first is x minus 1 and then x plus 2. So to maintain the equality, you have to multiply the upstairs by that as well. Now compare these two. Here you have x minus 1 quantity squared. Here you have the same thing. So it is multiplied by x plus 2. So upstairs should be multiplied by x plus 2. This is there. So it is multiplied by x minus 1 quantity squared. So C should be multiplied by the same. Again, do the same. Huh? You expand that, gather similar terms. Here you have x squared plus 2x minus 6. So that is plus x. Minus 1 times 2, minus 2. Now, expand this, you get x squared minus 2x plus 1. Now, gather similar terms. Now, we'll do it a little faster. Now, there are two terms carrying x squared. Now, I don't think, this is not necessary. It is not necessary to write, go through this step. Since it was our first problem, I went through like that just to show you what's going on. But instead, if you just concentrate only on these two, you can pull out x squared. So what are the numbers you get? A plus C, right? If you pull out x squared from those two, you get A plus C. Now there are three terms carrying x. Here, you have another term here. So it is AX, so you get A. It is BX. Once X has been pulled out, you get B. This is minus 2CX. When X has been pulled out, you get minus 2C. Finally, the constant terms, minus 2A, 2B plus C. Right? You can leave it as the final answer. Because you need this for partial fractions. So you exactly need to write it like that. Now you go for this. A over x, b over x squared plus c over x plus 1. A over x Now, what is the common denominator? X cubed times x plus 1 or x squared times x plus 1. Because when you have x squared contains x. Therefore, it suffices to have x squared times x plus 1. Now, you compare it with this. Now, this is multiplied by x times x plus 1. X times x plus 1. So, to hold the, to maintain the equality, you have to multiply the upstairs by the same. So, this is an equivalent fraction to this. Now go for this. You have x squared already, but the downstairs is multiplied by x plus 1 by an extra factor. So to maintain the equality, you have to multiply the upstairs by the same. Right? Now go for this. Downstairs is multiplied by x squared, so multiply the upstairs by the same. We will expand it. You get ax squared plus ax. Then here you have bx plus b. Because otherwise here you cannot see exactly where that x squared lies. So you will expand it like that. Now gather similar terms. Now there are two terms carrying x squared. Right? If you pull out x squared, what will be left in the bracket? A plus C. Right. There are two terms carrying x, ax and bx. So if you pull out x, you get a plus b. Then there's one constant, b. Right. Now the fourth, bx plus c over x squared plus 4. Now, just by multiplying these two, you can get the common denominator. It's not a big deal there. Now, multiply. Now, the downstairs has been obtained by multiplying these two. So, by crisscross multiplication, you can get the upstairs. So, a times x squared plus 4 x plus 1 times bx plus c. Now, you have to expand you have to expand the upstairs. Don't try to expand the downstairs. So you leave it like that. Now, the reason is that that's how you use in partial fractions. You need this for partial fractions. We'll go for that once we finish polynomials. Now, expand for a. Here, you get x times bx. You get bx squared, then x times c. You get cx 1 times bx. That is just bx. 1 times c is c, right? Now, there are two terms carrying x squared. When you pull out x squared from those two, from these two, you get a plus b, right? There are two terms carrying x. So if you pull out x from those two, you get b plus c or c plus b, whatever. There are two terms, two constant terms. So 4a plus c. Right. Always like pull out x squared or x cubed, whatever the highest power you have, get the constants, pull out the next power, get the constants. So you have to leave it like that. Because that's what you need to do in partial fractions. So let me do this as well. A over x minus 2 right. Again, what is the common denominator? You can just multiply these two. Now, okay. Since the downstairs has been obtained by multiplying these two downstairs, just by crisscross multiplication, you can get the upstairs. So a times this plus right. Now we'll expand. You can multiply everything by a. Then you have bx squared plus cx minus 2bx minus 2c. Now, connect these two. I mean, sorry, gather those two terms. If you pull out x squared from these two, you get a plus b. Hmm. There are three terms carrying x. 1, 2, 3. From this you get a. From when you pull out x, you get c and minus 2b. Now we have taken care of 5 terms. There are 2 constant terms left, a and minus 2c. Right. So you have to leave the answer like that. Okay, you take that down. Okay. Now here, this kind of a meaningless calculation, like we simply gather these terms and come up with an expression like this, right? The real meaning of this, I mean, why we need this, can be explained when we do or when we go through partial fractions. They are, in fact, this is what we do. If we have like some fractions, we simplify them and combine into one fraction, right? Here we have three. Here this just one fraction or one rational function. Say you are given something like this. How you break this into several simple fractions? That's the process of partial fractioning, but we do them probably 2 months from today. Hmm. At that point, I'll explain you how it is done. But to solve that particular problem, you need to carry out a simplification like this, right? Means that you have some constants like A, B, C. You take everything above one common denominator, then you simplify them like that, and then gather similar terms like coefficients of x cube, if any, otherwise x squared, x, and the constant terms. If you arrange it like that, then in the next step, you have to do, I mean, you have to proceed with this to get the final answer, but this merely a simplification we need there. This doesn't have a meaning at this point, but I just want you to know how to get the common denominator, and once you get the common denominator, how to figure out the upstairs, right? That's all what I want you to do at this point. You can do problem like 14 and 15 as your homework problems, right? 14 and 15. Next time when you come to the class, you go through those two. There will be a lot of subsections, like in 14 there are 8, in 15 there are 10. Hmm. And most of them are just Hollywood stuff. These are topics, so I leave it like that, completing a square. Okay. Now consider the expansion of x plus a quantity squared. Hmm. If you do that, you get x squared plus the term in the middle, which is 2ax plus a squared. Similarly, if you have a binomial expansion of this, x minus a quantity squared, you get x squared, then the term in the middle, minus 2ax plus a squared, right? Now just take one of them. Now, if you have these two terms, how would you figure out a squared? If you have just these two terms, how would you figure out the next term, right? Okay, you take the constant associated with x, right? You divide it by 2, you get a, right? Then square, you get a squared. Again, the case is the same here. You get this constant O even with the negative sign. You divide it by 2, you get a, now square, right? Okay, now let's go in the reverse direction. Say you have something like this. How do you write x in one place? Now x is in two places. If you complete a square, look, in this side you have x in two places. In the left-hand side, you have x only in one place. With that setup, you can handle it better. Like if you have x in two places, if somebody asks you the range of the function, you don't know what to do. If x is, or if you have, say, if you have a certain quadratic equation, if x is in two places, it's hard to find x. It's hard to make x the subject. But if you have x only in one place, you can easily handle that. So that's the basic idea of the completing of a square. Now, this is what we do. Now play the same trick. Oh, sorry. Look, when you have something like that, you have to figure this out. That's the basic idea of completing a square. Now, when you have x squared, get the square root of that. That is x. To figure out what you have in there, you just divide this number by 2. Whenever you have 2a, it will be a. Whenever you have minus 2a, it will be minus a. So get the square root of this. It is x. Divide this coefficient by 2. It will be minus 2. Raise it to its square. Now you know that there are three terms. X squared will give you this. You have minus 2x, sorry, minus 4x. That is this. And you have plus 4. This side, I mean, minus 2 squared, this guy. Now that is not there. I mean, in the left-hand side, you don't have plus 4. Right? Like x squared, the term x squared is shared by both sides. Minus 4x is shared by both sides. However, this side you have an extra term, 4. So these two sides are not equal because of that. So to make it equal, you have to subtract that 4. Right? Now these two sides are equal. But the only difference is that here, x is in two places. In the right-hand side, x is only in one place. Take another example. Now, how do you handle this? Get the square root of x, x squared, you get x. Divide this number by 2. If you raise it to its square, you get x squared. The term in the middle will be 2x. Now you have plus 1. That's an extra 1. 1 squared, subtract 1. What is now? Again, forget about this 7. You take care of these two. Write the square root of x squared, that is x. Now take this number, the coefficient of x, divided by 2. Raise the sum to its square. Now what happens? If you expand it, you get x squared. Then you have the term in the middle, which is 6x. However, here you have 7, here you have 9, 3 squared. This guy. Now, 3 squared was not there earlier. So you have to subtract that. That is 9. But you have to introduce this 7. 7 was there earlier. So this will be x plus 3 quantity squared minus 2. Right. Now, using this, we'll solve quadratic equations. Next time, we'll go through, we'll see how we find a range of a function. Then we can start functions. We can probably go through that next time, and then a week after the next, hopefully, we can start the regular syllabus, remainder theorem and polynomial functions. Right. Now, I mean, you can factor this, but still do it by completing a square. Right. I'll do the first and this third. And probably the sixth. Okay. So I'm going to solve them by completing a square. I cannot factor them. Of course, I can factor this. If I want, I mean, if I put a negative sign, then you cannot factor it. Then you have to stick to this method. Sorry, this is negative. Now, this is how you do when we use completing a square to solve quadratic equations. You leave excess in one side and take this to the other side. That would be better. Now complete a square here. Write the square root, divide this number by 2, raise it to a square. Now you have x squared here, yes, that's fine. The term in the middle, 2x, that is there, and 1 squared is here. You didn't have 1 squared earlier. Right now, that means you have an extra term here. So you have to subtract that. Now take that to the other side. So that will make it 2. Now get the square root. Because we want to make x the subject. So by solving, what we mean is that we want to make x the subject. Now you take the square root of both sides. When you take the square root, you have to write plus or minus and the square root of 2. Now bring this 1 to the other side. That will make it minus 1 plus or minus square root 2. I'll leave 2 for you. I'll do the third. 2x squared minus 8x plus 3. Here, to complete a square, the coefficient of x squared should be 1. Now it's 2. So you divide it by 2. Now we are fine. Take that to the other side. You could have done everything in one line. But I'm not doing it so because I want to be, for the sake of clarity, I do one step at a time. Now complete a square. How do you do that? Write the square root of this guy. It is x. Divide this number by 2. Raise it to its square. Now, if you compare it with this, these two are not equal. You have x squared here, you have minus 4x, but you have an extra term here. What is that? 2 squared, which is 4. So you have to subtract that. Now you have to bring that to take that to the other side. It will make it positive. Right? What will this be? If you take a 2 as the common denominator, you get 8 minus 3, 5. Now get the square root. I'll do it here. X minus 2 is the square root of this. You get the square root of the right-hand side. For one side, you have to introduce plus or minus. In fact, you could have done it to this side as well. However, if you do that, we will be in trouble. Right? We can make our life easier if you put plus or minus to the side where you don't have the variable. So plus or minus. Now x is 2 plus or minus this. So in the same fashion, you can do the fourth and possibly the fifth here. I'll do this one for you. I'll have to make it minus. Otherwise, I get complex numbers. 6. Again, the coefficient of x squared is 1. So we don't have to worry too much about it, but take that x minus 1 to the other side. So it will make it positive. Now complete a square. The square root of this is x. The coefficient here is 1. So you have to divide it by 2. You get half. If you do that, this is not exactly equal to this. Why? You have x squared. 2ab term is equal to x. However, you have 1/4 here. 1/4 was not there in the upstairs. So it's an extra term. So you add it to this one, you get 5/4. You can do that, right? Oh, so when 4 is the common denominator, you get 5/4. 1/4, right? Now get the square root. You have to introduce plus or minus to one side, but usually you introduce it to this side. It will make your life easier. This minus half, plus or minus. When you get the square root, you can take the square roots of both upstairs and the downstairs. It will leave you with this, right? Okay, you do the other parts. 2, 4, 5, and 7. And we can wind up with this problem. So you do those. If you have a difficulty in the 7th, I'll do it for you. Right? Okay, I'll do the 5th and the 7th towards the end, but you try them out first. Okay. I do the fifth and the seventh. Again, in the fifth, the coefficient of x squared is not equal to 1. So to make it 1, so divide it by 2. And at the same time, you can take this guy to the other side. So you will end up with this. Now you have to complete a square in the left-hand side. Get the square root of x squared. Divide this by 2. Now, if you write it like that, it is not exactly equal to this. You have x squared. You have the term 2ab term is exactly this. You have an extra term, 9 over 16. So that is there. So you have to subtract that to make this equal to the left-hand side of the term or the above step. Now, take this to the other side. Now we are almost done. We have to make x the subject. You can take x, 16 as the common denominator. You have 9 plus 8. This is 17 over 16. Now get the square root. So if you get the square root, you get x plus 3 over 4. This side you have that. Introduce a plus or minus to the side where the variable is not there. Now variable is not, the side which has constants only. Now take this to the other side and you can get the square roots of these terms separately. The square root of 17 is this. The square root of 16 is 4. Right. Now the seventh. It is this. At the first place, you need to notice that the coefficient of x squared is a. So you have to divide it by a. You have to mention that a is not equal to 0, otherwise you cannot divide it by a. Now, this is a constant, you can take it to the other side. So it will be minus c over a. Now complete the square in this side. The square root of x squared is x. The square root of this is, the half of this is b over 2a. b over 2a. Right? However, these two sides are not equal. Why? Because you have x squared. The term 2ab is, these two will go away. It leaves you with bx over a. Yeah, that's also fine. But you have an extra term here. It is the square of b over 2a. b over 2a. The square of that. So you have an extra term here. So you have to subtract that. The square of this is b squared over 4a squared. When you square some fraction, you have to square each and every term in the fraction. When you distribute, like you have distributed, like when you have plus sign in between, you cannot do that. When you have multiplications and divisions, then you can square each and every term. Now you have to make x the subject. So take that to the other side. Right. Now you can take the common denominator in the right-hand side. So this is b squared minus. Now you need to have 4a squared in the downstairs. You have an a there. So you have to multiply the downstairs by 4a to make it 4a squared. So to hold the equality, you have to multiply the upstairs by 4a as well. Now this is the time to get the square root. So when you get the square root, you get x plus b over 2a. In the right hand side, you have to get the square root. Now introduce the plus or minus. Now when you have something like that, take the square root of both upstairs and downstairs. Upstairs you cannot take it because there's a negative side. Here it's a product. So you can take the square root of each and every term. Now take this to the other side. Now take 2a as the common denominator. So you will get the quadratic formula if you do that. Okay. You take that down. Last thing. Okay, once you are done with this, you do problem 19 as a homework problem. Next time when you come to the class, do all of them. So next time we can start functions, but it is not the syllabus. We just see how we do substitutions, long division and stuff like that. So I assigned few homework this time. Because of this, you have a squared is 4ac. 4ac. Huh? No, it's okay. This you don't get an a there because you already get 4a squared. Yeah. And one is minus, the other is plus. This minus. Right. All right. Once you're done with this, You do problem number 19. We'll go through a little bit of this again. I mean, how to find the range of a function, then we can start, how to find the range of a quadratic function, then we can just go through polynomial functions next time, and then we can start the regular syllabus week after the next. All right. So I'll see you next week. Hopefully in the class. Right. Have a nice week.